All right, what's in polluted water? Our first note of our environmental chemistry unit. We're going to look at three things today that can pollute our water supplies, and most of these things are very common. Water is obviously super important for humans and whatnot. So, there's three different types of contaminants. Our first one we're going to talk about is a physical contaminant. Physical contaminant is just any object that does not dissolve in water. So, this can be fats, this can be just solid garbage. It can be debris. It can be kind of minerals like silt and clay, oil, garbage. All these types of things do not dissolve in water. All of these things, or some of these things, can be removed just by putting the water through a coarse screen. So much like you make coffee in the morning, you have a coffee filter that keeps the grounds out of the actual coffee. You can filter these things through a coarse screen. You can skim off oil. So when oil spills in the ocean or on lakes and things like that, it can be skimmed off by some methods like that. Or you can have these settling tanks, which will allow silt and clay to kind of sink to the bottom. But physical contaminants are important to remove. Obviously, you don't want to have floating pieces of garbage floating around in any drinking water supply. The second type of contaminant is a biological contaminant. So these are things like bacteria and viruses that exist in the water. These, again, remember, bacteria and viruses, they naturally occur in our water already. We just want to make sure that we limit the harmful bacteria and the harmful viruses that could hurt us. So, for example, before my family goes swimming in the summer, we always check the website to make sure that the beach is open. A lot of the times, can be closed in the summer because water is contaminated. It's kind of gross, but it's fecal coliform bacteria. Um, and again, that comes from a lot of agricultural runoff and things like that. It can come from incorrect disposal of human waste as well. The city of Walkerton in May 2000 had a huge issue with a biological contaminant. They had E. coli bacteria in their drinking water supply. It came from runoff of a farmer's field who was incorrectly applying compost. And then the people who were testing the water didn't do a good enough job to remove that E. coli bacteria that was there. It actually killed some people, and about a third of the town got sick. So the Walkerton's about the same size as Lucan. It was a huge issue for the residents there, and it still reverberates in Ontario to this day. Because what happened was they had lots of stronger laws and control for our drinking water. The third type of contaminant we're going to talk about is chemical contaminants. Obviously, this is chemistry class. We're very concerned about chemical contaminants. These are substances that are soluble in water, and that is a lot of different substances. And again, some of these things can be as simple as salt water, or some of it can be as dangerous as elements we don't want to intake in our body in very high amounts, like lead or arsenic. Um, Manufactured chemicals, metal ions, pesticides, fertilizers, pharmaceuticals, these are all things that can dissolve in water. We don't want them necessarily in our water supply. So if you improperly dispose of chemicals, they can run or leak off or leach into our water sources. And how we deal with these things, you can remove them by doing some chemical reactions and having a precipitate form. Filtration can be an option, or by distillation, so boiling the water and having it evaporate, catching that evaporation, cooling that back down, so condensing that steam, and it will leave the impurities behind. So we are going to do some calculations with chemical contaminants. Okay, there's something called a maximum acceptable concentration, and we're going to talk about this in the little assignment you're going to do. My house, for example, I live in an older part of London, and lead pipes were used historically to deliver water into our households. Now, lead, if you're over the maximum acceptable concentration, the MAC, it's not very good to drink. And obviously, when we moved to our house, we had young kids. We ourselves didn't want to be drinking water that had lots of lead in it because it can have neurological effects and things like that. So they came and sampled my water. So here's an example. Someone goes to a house and they take a 25 milliliter sample of water, and it's tested in a lab and found to contain 0.0051 grams of lead. It might seem like a very small bit of lead, but let's see is this water safe to drink. Now, there's a table in your textbook. I'm going to post this for you, and it communicates all the maximum acceptable concentrations, the MACs. Now, to do this, we have to find parts per million. Parts per million is the units for it is we have to have masses in milligrams and the volume in liters. So we have to take our numbers here, 25 milliliters, and our mass, 0.0051 grams, and convert these things into milligrams for the mass and liters for the volume. So our first step, we know that there's 1,000 milligrams per gram. So we take our grams and we multiply it by that 1,000 milligrams per gram. The grams will cancel out and we're left with 5.1 milligrams. Now all of a sudden our number starts to seem larger because our units have changed it into milligrams. For liters, we have to divide. So 25 milliliters divided by 1,000 milliliters per liter. The milliliters will cancel out. We end up with 0.025 liters. Now all we need to do to find parts per million is take the mass in milligrams, divide it by the volume in liters, and we'll get this milligram per liter value, which is parts per million. So here it is here, milligrams divided by liters, or mass divided by volume, 5.1 milligrams divided by 0.025 liters, and we end up with 204 parts per million of lead. So if we had a million parts, 204 of those million would be lead. It seems like a very small number. Now we have to go and try to find what is the maximum acceptable concentration of lead. And the allowable limit of lead is 0.01 parts per million. So this 204 is obviously way over that 0.01 parts per million. So this sample is not safe to drink. Now I was lucky, this isn't my house or anything like that, but there are people who have a fair amount of lead in their drinking water, and this wouldn't be safe to consume. Let's do one more. Okay, one more problem here. So this example is arsenic. So a 10 milliliter sample of water is tested and found to contain 0.0000022 grams of arsenic. Is this sample safe to drink? We have to convert this into parts per million, or milligrams per liter is another way of saying that. So we're going to find that. So our mass needs to change into milligrams. We times it by 1,000 milligrams per gram. The grams will cancel out. We were left with a unit of milligrams, so we have 0.0022 milligrams. Our volume is not in liters. We've got 10 milliliters, got to divide it by 1,000. The milliliter units will cancel out, and I have 0.010 liters. Now we take the milligram divided by liters, and we end up with a parts per million is 0.22 parts per million of arsenic. Now, again, we have to look up the MAC, or the maximum acceptable concentration of arsenic in water. The allowable limit is 0.025 parts per million. Because this number in our sample is higher than 0.025, this sample is not safe to drink for arsenic. A point to make out is if we were under the MAC, the maximum acceptable concentration for that element, it doesn't automatically mean that the water is safe to drink. It could be unsafe to drink in other parts. There could be other metals or harmful things dissolved in the water, but this is just a case-by-case example. If we were looking specifically for arsenic, this sample that we're looking at is not safe to drink. Okay, I'm going to get you to do a little worksheet. You're going to go through, again, I'm going to post all the MAC values, that table on the Google Classroom, so you'll be able to compare that up, and all of the answers as well will be posted for you. Okay, so that's the end of our note. There's a little thing on MAC. Yeah, you know me.